Hello, Assalamu alaikum students. So let's begin with a new chapter on pressure and its measurement. So let's continue with numerical problems. A simple U-tube manometer contains mercury, is connected to a pipe in which a fluid of specific gravity 0.8 and having vacuum pressure is flowing. The other end of the manometer is open to atmosphere. Find the vacuum pressure in pipe if the difference of mercury level in two lumps is 40 centimeter. The height of fluid in left from the center of the pipe is 15 centimeter below. So in this problem the figure won't be provided to you. In the statement the description is sufficient to draw the figure yourself. So they have given that it is a U-tube manometer and in which an oil of specific gravity 0.8 is flowing and it has vacuum pressure. So this has been insinuated that it is vacuum pressure. So as we know, when the pressure inside the pipe it is higher, so the mercury level in the other limb it will be higher. If the pressure is reduced, then the mercury level will also be reduced, it will be lowered. So the other end of the manometer is open to atmosphere, as always the case. So find the vacuum pressure in pipe if the difference of mercury in two limbs is 40 centimeter and the height of fluid in the left limb from the center of the pipe is 15 centimeter. So they have given from the center of the pipe, so liquid level is 15 centimeter and the difference level of mercury in two limbs is 40 centimeter. So the only thing to be considered is whether this 40 centimeter will be in the left limb, the major difference will be in the left limb, or it will be the right limb. Or what I want to say is that would the mercury level be higher in the left limb or in the right limb. So as they have given that the vacuum pressure is flowing, so it is better to assume that this difference will be in the left limb. So let's write the equation. As I've always suggested you that to write the equation yourself, do not follow any formula because it will be different for each case. So we begin with the pressure at the center and they have used a symbol P, and I would recommend to use a direct method. So as we go downward, we'll use positive sign for pressure at P, and as we go downward the pressure would increase by rho GH, where rho is the density of this flowing fluid, into 9.81 into 15 centimeter. You have to convert 15 to centimeter to meters. So this rho 1 is the density of the flowing fluid and h1 is this height, which is 15 centimeter, 0.15 meter. And again we are going downward till the datum AA, and the density is rho 2, which is given it is mercury. For mercury you must remember the density, it is 13,600 kg per meter cube and its height is 0.4 meters over here. So they have simply rearranged the expression, they've taken these terms to the right hand side and solved it, and you'll get your answer in Newton per meter square. So next numerical, a U-tube manometer is used to measure the pressure of water in a pipeline which is in excess of the atmospheric pressure. Again with this statement the figure won't be provided, so they have given that it is a U-tube manometer and the pressure is in excess of the atmospheric pressure. So this means that the pressure is greater than the atmospheric pressure, that it is a gauge pressure. So right limb of manometer contains mercury and is open to atmosphere. So the manometric fluid is mercury and the contact between water and mercury is in the left limb. So here they have made it clear that the contact between the mercury and water is in the left limb. Determine the pressure of water in the main line if the difference in the level of mercury in the limbs of U-tube is 10 centimeter and the free surface of mercury is in level with the center of the pipe. So first of all, you have to determine the pressure inside the pipe, and the second case is if the pressure of the pipe, pressure of water in the pipeline is reduced to 9810 Newton per meter square, calculate the new difference in the level of mercury, sketch the arrangement in both cases. So please look at this left figure first. We basically have to draw it ourselves from the description given in the statement. So we have this U-tube manometer, and it was given that the manometric fluid is mercury, and the other end is this D end is open to atmosphere, and the contact between water and mercury is in the left limb. So here we have the contact, and so the difference in the level of mercury in the length of U-tube is 10 centimeter, and the free surface of mercury is in level with the center of the pipe. So this D point is till the center of the pipe. So D point matches with this A point with the center of the pipe, and the level difference is 10 centimeter. So once you have drawn the figure, now it is easy. You know this BC is going to be our datum, and we can very easily write the pressure equation. And we'll start from the pressure at point A, PA, we're going downward. So pressure increases by density of water, 1000 into 9.81 into 10 centimeter, convert centimeter to meters, use SI units, use all values in meters, it will be more simple. So 0.1 meter, then move to the datum, and now we are going upward, so pressure would be reduced, so it is minus 13,600, which is the density of this manometric fluid mercury, into 9.81 into 0.1. So now this is equal to 0, right? So now simply rearrange the expression and find out the pressure at point A, and the solution, the answer is written over here. It will come out to be 12,360.6 pascals. So the next step is this complete solution is also given in the next slide. This problem has been taken from R.K. Bansal. You can also refer to the book, and I've also added the solution in the next slide, but I want to explain the figures over here. If the pressure of water in the pipeline is reduced to 9810 Newton per meter square, now the pressure which was 12,360, if it is reduced to 9810 Newton per meter square, calculate the new difference in the level of mercury. So as we know, the pressure at point A, if it will be reduced, so the mercury level over here, it will be dropped. So mercury level drops from D to D star. And as the length of the mercury, it is same. Quantity of mercury in the pipe is same, right? So the mercury level will be rise in the left limb. It will rise from this B to B star. So I'll repeat once again. As the pressure at point A, it is reduced. The pressure inside the pipe has reduced. So the mercury level, which was initially at D, it will go down to D star. And in the left limb, the mercury level, it will be raised, and it will go from B to B star. So this basically it indicates we have to shift our datum. Now the datum will be shifted from BC to B star C star, and this drop from D to D star, this is equal to X, and this rise from B to B star is also X. It is equal, right? And as we have shifted our datum to B star C star, so they have asked us to determine the new level difference of mercury in two limbs, which will be from C star to D star. So it will be 10 minus 2x in centimeters. I would also recommend that you must assume that the x is in meters, and this 10 centimeter, it is also converted to meters, so it is 0.1 meter. The calculation becomes much more simpler by this way. So we'll take it is 0.1 minus 2x, where x at the end we'll get in meters. So again we'll write the pressure equation. We'll start from pressure inside the pipe PA, which is known 9810. So as we go downward, the pressure has increased till B star. The height is 0.1 minus x. Then and the density you already know that. Then we'll move to C star, and as we are going upward, so the pressure would reduce minus the density of this mercury 13,600 into 9.81 into 0.1 minus 2x is equal to 0. So I'm hopeful that you must have developed the equations. Once the equations are with you, simply open up the brackets and rearrange and simplify to get the x value in meters. Then you also have to determine the level difference of mercury. Let me show you in the next slide. Yes, this is a solution for the first part, and this is a solution for the next part. Here the x will come out to be 0.992 centimeters, and for you guys, I prefer to get the answer in meters and then convert to centimeter, or any way you want to do it. So at the end, the answer should be 8.016 centimeters. So let's move on to the next numerical. Problem number 12. A conical vessel having an outlet at A to which a U2 manometer is connected. So in this statement, this figure will be provided. This is a pipe outlet A to which a conical vessel is connected, and to the other end we have a U2 manometer. The reading of manometer given in the figure shows that the vessel is empty. So initially this vessel is empty. Find the reading of manometer when the vessel is completely filled with water. So this conical vessel, this has 2 meter diameter and 3 meter in height, and the height till the datum XX is H1. So this reading H1 is not provided to you, while the level difference of mercury in two limbs is given. It is 20 centimeter. So you have to determine this new level difference of mercury when this vessel is completely filled with water. So first of all, we have to determine this H1. So for that, we'll start from this point PA. Now this should be my question. What would be the pressure at point A? So it is given that this outlet A, this is attached to conical vessel. So this means that this vessel is empty. So this point A has atmospheric pressure. And as we are measuring gauge pressure, so it has to be taken equal to 0. So pressure at point A is 0. As we go downward, the pressure has increased by, so this is filled with water, right? So density of this liquid is water. So 1000 into 9.81 into H1. We'll assume that this H1 is in meters. Then follow the datum, and now we are in the other limb and we are going upward. So pressure reduced. So it is minus 13,600 into 9.81 into 0.2. Convert the centimeter to meters, right? So now the second part, where they say now the this vessel, this is filled with water. So the height of the water is now 3 meters. So now over here, pressure at point A, it cannot be 0, right? How can we calculate the pressure? By simply rho gh, where the height is 3 meter. Okay, so you can calculate the pressure at point A, and as the pressure at point A has increased, so the mercury level in this limb, it should go higher, and let's say that it goes higher by Y. So as the mercury level has rise in this limb, so in the other limb it should go down. So our datum will be shifted from XX to ZZ. So datum has gone down by Y, and so the level difference of mercury of two limbs will be the distance from this datum ZZ to this new level which has gone higher by Y. So the level difference will become 20 plus 2Y in centimeters. So developing the equation for the second case, the pressure PA will be rho GH, where H is 3 meters, and we go downward, so pressure has increased till datum ZZ by height will be H1, which was computed earlier from the first figure, plus Y. Y is unknown, it is to be determined. And then we have moved to the data, we're going upwards, so pressure would reduce by minus 13,600 into 9.81 into 20 plus 2Y. I recommend that you use meters instead of centimeters. So you can write equation form of 0.2 plus 2y, where y will be in meters. So solution is provided in the next slide. Go through it, solve it, and if still you have any query, we can discuss it in our online session. So your answer at the end would come out to be 42.90 centimeters. So the last numerical, I believe you will be able to do it yourself, and we'll discuss it if you have any query. And that's it from this topic. Thank you so much. Allah Hafiz.